we shall be looking at quadratic equation. Without wasting time, we shall be proving the almighty formula. From the general quadratic expression, ax squared plus bx plus c equal to 0. If you are expected to prove the almighty formula or the general quadratic formula from this general quadratic expression, what we do is to divide first through by a, and that gives us x squared plus b over ax plus c over a is equal to 0. So 0 divided by a is 0. Now, we are going to use completing the square method. The first step is to transfer c over a to the right hand side. We now have x squared plus b over ax equal to minus c over a. Now, as it were, what we do, we introduce completing of the square method by multiplying r squared, the coefficient of x, to both sides. And this gives us x squared plus b over ax plus 1 over 2. 1 over 2 multiplied by b over a all squared is equal to minus c over a plus 1 over 2 b over a all squared. All squared. This is completing of the square method. When this is subtracted, transferred to this right hand side and subtracted, it will remain the same equation. But the essence of this is to complete the square by factorization methodology, so that we will now be having x squared plus b over ax plus b over 2a all squared is equal to b squared over 2a all squared, which is the same thing as 4a squared, minus c over a. We have squared this part, and this is it here. We have squared this part, and this is it, 4a squared. So you take one of the squared terms at the left hand side, and this is the completion of square methodology of getting the square of the quadratic expression. So that you pick the square factors. The square factors are x and b over 2a. Square it to give us x plus b over 2a all squared is equal to the LCM between this and this is 4a squared. And 4a squared here gives us 1. Multiply b squared, minus a into 4a squared will give you minus 4a. So that we now go in for further work by introducing the concept of square root. It now becomes square root function of x plus b over 2a all squared is equal to plus minus roots of b squared minus 4a. Now remember that when this a is here, it goes into 4a squared, and this is giving 4a. This 4a multiplies c gives us 4ac ab initio. Gives us 4ac. So that what we have here is 4ac. Take note that this c must be reflected in the expression. So when a goes into 4a squared, it gives us 4a. To multiply c to give us 4ac. Divided by 4a squared. Now, this square cancels the square root to give us x plus b over 2a is equal to plus minus root of b squared minus 4ac divided by 2a. As square root of 4 is 2, square root of a squared is a. So we transfer plus b over 2a to the right hand side to now get, therefore, x is equal to minus b over 2a plus minus root of b squared minus 4ac all over 2a. getting LCM of these values 2a and 2a, we will now be having, clearly, we'll be having 2a, so that x is equal to minus b plus minus root of b squared minus 4ac divided by 2a. As the common LCM is 2a. And this is the general quadratic formula for solving quadratic equation. This is the general quadratic formula for solving quadratic equation. This is the proof methodology. Starting from here, when we have a question like this, this is a quadratic equation sample. This quadratic equation, ax squared plus bx plus c equal to 0, ab initio, is the standard expression for quadratic equation. When you are to solve this, using completely the square method to get the general quadratic formula or the almighty quadratic formula, we divide first by the coefficient of x squared, which is a, we get this expression. This is a review. I have treated it before, so I'm trying to repeat my process work for clarification. Now, transfer plus c over a to the right hand side to have x squared plus b over as equal to minus c over a. What we do, we now introduce completing of the square method. Completing of the square method, we add half of b over a squared to both sides. So when this is squared, you have this appropriation. So we pick the square values of this equation, which is x and b over 2a, and square them. Lo and behold, if you expand this, you will get this expression. They are equal. This and this are equal. Now, if you square b times 1 squared, gives you b squared, b squared. Now, if you also square 2a all squared, you will have 4a squared. This value, when re-expressed, you get this, minus c over a. So LCM of 4a squared and a is 4a. That's what we said, 4a squared. Because 4a squared is here and a is here. A can go into 4a squared, 4a squared can go into 4a squared. So we'll have 4a squared here. So therefore, if LCM is this, 4a squared into 4a squared gives you 1, multiply b squared gives you b squared. Now, a into 4a squared gives us 4a, multiplied by c gives us 4ac. Now, we progress to find the square of both sides. We'll find the square of both sides. We'll find the square of both sides. We'll find the square of both sides. The both sides square is now going to be a value that will nullify the square, and that value is square root function. Introduce square root here and introduce square root here. This square cancel this square root to have this value, and you have this, because square cancel the square root to have x plus b over 2a equal to root of b squared minus 4ac all over 2a, because square root of 4 is 2, square root of a squared is a. Then furthermore, we have finally the LCM of this and this is 2a. That is why we are having 2a here. So that gives us minus b plus minus root of b squared minus 4ac all over 2a.